Hello and welcome to another day of Advent of Code 2023, and today we are taking a look at puzzle number 11 and see my solution for that one. So let's see the puzzle first. So in this puzzle we have an image which is a map of the galaxies. The empty dots are empty space and the hashtag marks are the galaxies. And the thing that we need to find is to find the distance between each of the galaxies, between each pair of the galaxies, and we should do it one way. So if we count the distance from here to here, we don't need to count it from here to here again. But that's not so trivial. First we need to take a look at every row and every column and find the empty rows and empty columns and provide a new line and column for that one. So what do I mean? So for example, if we take a look at this example, here we have an empty row. It should be doubled. So we need to provide the row beneath this with an empty space, and the same goes for the column. So for example, when this column is an empty, the third column, the fourth column should be empty and all these points should push one to the right. Okay, so how can we solve this puzzle? So my approach is that I would get this image and then create a new grid with new rows and new columns, and then I would work on that one. So let's see how I would do that. Here first I would get the input, split it by new line and filter the empty ones. And here I would split it based on empty space to get a grid. Now I need to find the new rows that I need to add to this grid, and that is done by checking each row and see that if that row has some galaxy inside. If that's the case, then we just push the row to the new rows, so it would be the same row. Otherwise we push that row twice. Now using this one we have a new rows system, which the rows are doubled if they are empty. Then I would create a new grid based on the rows that I have, and at first it's empty. Then I would check all the columns here, and that is done like this, taking the first row, the length of the first row, and then doing a for loop. At first I would suppose that the row is empty, then I would check all the cells on that column using this, and if I find a galaxy there, then I would say the empty is false and I would break from the loop. At the end, whether I find a galaxy or not, I would go here. If I have not found any, so the column should be the same, I would map through that column and push it to the new grid. Otherwise, the column is empty, so I need to push two columns of empty. That will be done here. And here I don't need to go and get the new rows of I and j. I already know that these rows are empty, so it's okay to provide the empty here as well. So now, using these two for loops, I now have a new grid based on the grid and the rows and columns that are doubled. Then I would get the galaxies, and that's pretty easy. I would map through the new grid on each row and each column, and if that cell is a galaxy, then I would just push it to the galaxies map. And here I would have a galaxies array, which is something like this. For example, 1 and 2, and then for example 2 and 4, and so forth and so on. Then for getting the distances, I would have two for loops, one going from the 0 to the length and the other one going from the next step in the galaxies array to the end, so that I just count the next ones and I don't go back. And here I would just provide the simple function here to calculate the distance between those two values, and that's pretty simple. Here I would just get the x's from those two values, the start and end, which is in the index 0, and then the y's, and get the abstract values so that I don't include any negative values here, and just add those values together, and that would be my distance. So this is for part 1. For part 2, it gets a bit different, because instead of just adding one line, we need to add 1 million empty rows or 1 million empty columns. And that's not possible here using this approach the space that we need and the calculation time would be very large. So we need to come with another approach. Here in part 2, I don't provide any new grid as I did in part 1. Here, I would work on my current grid. I would first get the galaxies, which is the same as part of 1. Pretty standard, going for 2 loops and then finding the grid. Then I would find all the empty rows, and that is just a for loop going from the bottom to the top. Say that, okay, this is empty row. Now I would check all the columns to see if that row is really empty or not. If that row is empty, then I would check all the galaxies and I will find the galaxies which their y value is greater than the row value that I find here. If that's the case, I would add this number to the y, which means that these galaxies have been pushed 1,000,000 minus 1 times downwards. And the same goes for the columns. I have the same loop that I have here, but just for the columns, and I would add it to the rows, this value. Now I would have a grid with new distances added to the galaxies that we find here. And then the rest would be just easy. I would those two values and get the path length as before, as we have here. So the point here is that, again, the difference is that for empty rows, I would go from the end to the first row and I would find the empty row. And if that empty row is found, all the galaxies that are after that row should be moved like 1,000,000 minus 1 times to the bottom. So that's done by this. And yeah, that's for it. As always, the code is on my GitHub channel for you to go and check. And if you have any comments or suggestions, please provide it either on the GitHub or here. I would really appreciate that. And in the end, if you like the video, please provide a like, comment, or even subscribe to my channel. Thank you for watching and see you in the next video.